CompTIA Cloud Plus, new security controls. Well, as you noticed here, I put the word new in quotes. There's a reason for that because in the objectives of the new Cloud Plus exam, they list topics here such as data loss prevention, DLP, IDS and IPS, intrusion detection, intrusion prevention services, DDoS protection, distributed denial of service, and network access control lists, NACLs. Well, if you're a security professional, you already know that those are not new security controls. However, what CompTIA wants you to understand, and we'll talk about it in this lesson, is how cloud computing and next generation solutions have actually made these new security controls. So in this lesson, we're going to be looking at next generation DLP, cloud-based IDS and IPS, starting with next generation cloud DLP. The CompTIA approach reflects a shift towards more adaptive, cloud-native security strategies. While the certification doesn't define a single product, remember it's vendor neutral and vendor agnostic, it does emphasize the principles and capabilities that modern cloud DLP solutions should support. Okay, well, what are some of those modern solutions? Let's take a look. Cloud native integration. Next-gen cloud DLP works seamlessly across public, private, and hybrid cloud environments. It integrates with cloud service providers like AWS, Azure, and Google Cloud using APIs and native controls. Context-aware protection. This goes beyond static rules to assess user behavior, data context, and risk levels. It supports dynamic policy enforcement based on location, device, and access patterns. Data discovery and classification, automatically scanning cloud storage, databases, and SaaS apps to identify sensitive data. This technology uses AI, ML, to classify data types, for example, PII, PHI, and financial records, and then apply appropriate controls. It detects and blocks, in real time, unauthorized data transfers. It alerts security teams, for example in a security operations center, or maybe a cloud-based SOC like Security Hub at AWS, to trigger automated remediation workflows. Granular policy controls, enabling fine-tuned access policies based on user roles, data types, and compliance requirements. This supports encryption, redaction, and quarantine actions. And next-gen cloud DLP aligns with regulatory frameworks like GDPR, HIPAA High-Tech, PCI DSS, and in the U.S. FedRAMP. And it generates audit trails and compliance reports for cloud data activities. There's more. Support for DevOps and automation, data loss prevention integrating with CI/CD pipelines to enforce DLP policies during deployment, and using infrastructure as code IAC and orchestration tools to maintain consistent security posture. And then multi-tenant and multi-cloud visibility, providing unified dashboards and analytics across multiple cloud platforms. This helps organizations manage data risk in distributed environments, for example, a distributed data lake. Hopefully at this point in your career, you're familiar with intrusion detection and intrusion prevention systems. On the Cloud Plus exam, we want to focus on next-generation cloud IDS and IPS. As emphasized on the certification exam, this reflects a modern approach to securing dynamic cloud environments. These systems go beyond traditional perimeter defenses to offer adaptive, cloud-native threat detection and response. Some of the characteristics of next-gen cloud IDS and IPS is a cloud-native architecture. This is designed to operate across public, private, and hybrid clouds, integrating with the CSP, often using APIs, like RESTful APIs, and gRPC. Behavioral and signature-based detection. This uses both known attack signatures and behavioral analytics to detect anomalies. It employs machine learning to identify zero-day threats and insider attacks. Automated threat response. supporting real-time blocking, alerting, and remediation workflows. Next-Gen Cloud IPS can isolate compromised resources or trigger policy changes automatically. And scalable and distributed monitoring, monitoring traffic across virtual networks, containers, microservices, and serverless functions. And it scales horizontally to support multi-cloud and high-throughput environments. Other features of Next-Gen Cloud IPS is integration with SIEM and SOAR systems, feeding data to, let's say, Splunk, powered by Cisco, and it works with SOAR systems for coordinated defense. Encrypted traffic inspection. These systems are capable of inspecting SSL/TLS traffic without compromising performance, and they used cloud-native decryption methods to maintain visibility. Policy-based controls, allowing granular control over traffic flows, user behavior, and application access, supporting adaptive policies based on threat intelligence and risk scoring, such as the CVSS, part of the NVD database from MITRE.org, and, of course, compliance and audit support. The next topic is protection for distributed denial-of-service attacks in the cloud. Before we do that, let's look at a diagram real quick. Notice in this diagram that we have a subnet, subnet 1. This is a public subnet. It's going to use an internet gateway going out to the internet. So if you have an instance in this public subnet and it wants to go get a web page, for example, it's going to send its packet to the internet gateway up here. Now, a security group firewall is a stateful firewall, so it's going to allow the traffic to come back without having to allow it on an inbound list. So if this instance of Linux or Windows goes out and gets a web page, the security group firewall, being stateful, will allow it back in. However, the cloud provider, or CSP, is running a service on this internet gateway. That's going to be a protection service against common DOS attacks, denial of service, and distributed DOS attacks, usually in the form of botnets. At Amazon Web Services, this is called AWS Shield, and you have two options. You have Shield Standard and you have Shield Advanced. I'm up at AWS looking at AWS Shield Standard's overview. Shield actually works in concert with other services, for example, the Web Application Firewall. Shield is a managed threat protection service that protects your perimeter. For example, that internet gateway that I just showed you. But you can run Shield other places. For example, an API gateway. So Shield Standard provides DDoS detection and mitigation for free. And that's the great thing about Standard, is that it doesn't cost you anything. As long as you have an account in good standing, you're getting that protection. But what about Shield Advanced? Well, that's going to cost you. And in fact, most cloud providers offer some type of advanced DDoS protection. So the deal with Shield Advanced is you have to pay extra. It's not that expensive. However, at AWS, Shield Advanced gives you access 24 hours a day, 7 days a week to the DDoS response team, the DRT. So at AWS, you have to have one of those support plans that actually gives you support 24 hours a day, 7 days a week. You have to have the business plan or the enterprise on-ramp or the enterprise plan. So your charges can start to go up. But Shield Advanced is an awesome service, and all cloud providers offer standard denial of service protection and an advanced protection. Finally, we have network ACLs. You know, the access control list is not new. In fact, it's one of the oldest methods for protecting layer 3. It was called IP filtering daemons on Unix machines. Cloud network ACLs, or access control lists, are stateless, rule-based firewalls that operate at the subnet level to control inbound and outbound traffic. In other words, you have an inbound rule to the network, or the subnet, and an outbound rule. Each rule is evaluated in order, so they're usually numbered, starting with 100. And it applies independently to traffic directions, meaning return traffic must be explicitly allowed. These ACLs use criteria like IP addresses, protocols such as UDP, TCP, and port ranges to permit or deny access. offering granular control over network segmentation. That's what makes NACLs powerful, is they can have explicit deny statements, and we'll talk about how they can be used dynamically in a moment. Unlike security group firewalls, which are stateful and instance level, for example applied to the Windows instance or the Linux instance, network ACLs provide an additional layer of protection for cloud environments. In other words, additional defense in depth by filtering traffic before it reaches individual resources. As you can see in the diagram, Subnet 1 has a NACL and Subnet 2 has a NACL. And there's an inbound rule list and an outbound rule list. At Amazon Web Services, it might look something like this, where you have numbered rules, and then you're going to match on protocols and port numbers, and also the source address. In this screenshot here, we can see that we're designating a source of any, and notice there's no destination field in here. The reason why that's the case is because Amazon Web Services already knows what network or subnet you actually want to work on, so it knows the destination. But it's a numbered list, and it has explicit allow and deny statements, unlike a allow list or a whitelisting firewall like a security group. In the cloud, we want our NACLs to be dynamic. Dynamic updates to network ACLs in cloud environments are typically driven by automation, orchestration, and integration with cloud-native services. These changes help enforce security policies in real time based on system events, user behavior, or changes to the infrastructure. Some dynamic NACL triggers in the cloud could be IAC tools. Services like AWS CloudFormation or Terraform can update ACL rules during deployments. For example, when a new subnet is created for a microservice, Terraform updates the ACL to allow traffic only from specific IP ranges. Security automation platforms, cloud-native tools like AWS Config, Azure Policy, or Google Cloud Security Command Center monitor compliance and trigger ACL updates. For example, if a misconfigured ACL allows public access, AWS Config can auto-remediate by replacing the rule with a secure default. Event-driven triggers. Serverless functions like AWS Lambda or Azure functions respond to cloud events and then modify the ACLs. For example, when a suspicious login is detected, a Lambda function updates the ACL to block traffic from the source IP. You can also have dynamic NACLs in your DevOps pipeline. CI/CD workflows integrate ACL updates during application rollouts. For example, a Jenkins pipeline pushes ACL changes to restrict access to staging environments during testing. And then finally, cloud APIs and software development kits, SDKs. ACLs can be programmatically updated using cloud provider APIs. Some more real-world examples. At AWS, you have an EC2 instance launched in a sensitive subnet. Lambda updates the ACL to block all but the whitelisted IPs. At Azure, a new service is deployed in Operator Nexus Fabric. An ACL is created via the command line interface with dynamic match configs for IP, VLAN, and ports. And then finally, at Google Cloud Platform, suspicious traffic is detected by Cloud IDS. The dynamic ACL update is an ACL rule modified via API to deny traffic from flagged IP ranges. I hope this lesson on next-generation cloud DLP, IDS and IPS, DDoS protection, and network ACLs was informative. I want to thank you for viewing. We'll see you next time.